Hello YouTube family, welcome back. Let's provide a solution given this nice algebra problem, which is x raised to power 3 plus x raised to power 2. This is equal to 150. So what is the value of x? Solution, okay? We have x raised to power 3 plus x squared. This is equal to 150, okay? So we'll have x cubed plus x squared. Subtract, we take 150 on the left hand side, we subtract 150, this is equal to 0, okay? Now 150 can be expressed as 125 plus 25, okay? So let's substitute this. We're going to have x cubed plus x squared, subtract, this is 125 plus 25, so this is equal to 0, okay? Now from here, we're going to have x cubed plus x squared, okay? Subtract 125, subtract 25, this is equal to 0, all right? Now from here, we can express this as x cubed plus x squared, subtract 125 can be expressed as 5 raised to power 3, subtract 25 can be expressed as 5 raised to power 2, this is equal to 0, okay? So let's combine x power 3 and 5 raised to power 3 because they have the same exponent. That's what we have x raised to power 3, subtract 5 raised to power 3 plus x squared, subtract 5 squared, this is equal to 0, okay? Now we have two parts here. We have the first part and we have the second part, okay? Now the first part, actually this is the difference of two cubes expressed as a cubed subtract b cubed, which is equal to a minus b, okay? This is a squared plus ab plus b squared, okay? So substituting what we have, x cubed subtract 5 cubed, this is equal to x minus 5, okay? This is x squared plus 5x plus 5 squared, which is equal to 25, okay? So this is our first part. I can call this is the first part. The second part is x squared subtract 5 squared, and this is actually the difference of two cubes expressed as a squared minus b squared, which you can express as a minus b and a plus b, okay? Now from our case, we have x squared subtract 5 squared. We can express this as x minus 5 and x plus 5, okay? I can call this the second part, okay? So let's recombine the first part and the second part as follows. So let's combine the first part and the second part as follows. We have x minus 5, okay? X squared plus 5x plus 25, okay? Now we have plus x minus 5, x plus 5, this is everything equal to 0. Now as you can see, x minus 5 in the first part is also the same here. We have in the second part, we have x minus 5. So we factor out x minus 5, okay? So that we are going to have x squared plus 5x plus 25 plus, this is x plus 5, okay? This is equal to 0, all right? So now the first part, which is x minus 5, we equate it to 0. We're going to have x subtract 5. This is equal to 0, so that x1 is equal to 5, which is our real roots, okay? Now the second part, we have x squared plus 5x. We can call this is 5x plus x. So this is 6x plus, this is 25 plus 5. So this is plus 30. This is equal to 0, okay? So we have x squared plus 6x plus 30. This is equal to 0. And this is a quadratic equation, okay? This is our quadratic equation, all right? Whereby this quadratic equation is in the form of ax squared plus bx plus c. this is equal to 0. So from this, we have a, which is the reading coefficient of x squared, is equal to 1. We have b is equal to 6, and we have c is equal to 30. Okay, so let's check if the nature of the root of this quadratic equation. So let's check using by calculating the discriminant value, which is b squared subtract 4ac. Let's check if it is less than 0. So you're going to have 6 squared subtract 4 times 1 times c, which is 30. So that we're going to have 6 squared, this is 36, subtract, this is 30 times 4, which is 120. Okay, so if you subtract this, we're going to have, so we have that 6 minus 120, this is equal to negative 84, which is less than 0. So this means that you have two complex roots. Okay, we have two complex roots or imaginary roots, which are in the form of x is equal to a plus ib. That is, I can call this x2, and also x3, which is in the form of a minus ib. Okay, so let's calculate this x2 and x3 applying the quadratic formula as follows. So we apply the quadratic formula, which is x is equal to negative b plus or minus this square root of b squared minus 4ac over 2a. Okay, so as you can recall, our a is equal to 1 from our quadratic equation, b is equal to 6, and c is equal to 30. So let's substitute these values, so that you're going to have negative b, which is negative 6, plus or minus the square root of b squared is 6 squared, subtract 4 times a, which is 1, times c, which is equal to 30, divide everything by 2 times a, which is 1. Okay, so this is equal to negative 6 plus or minus the square root of, this is 36, subtract 4 times 30, this is 120, divide everything by 2. Okay, now from here we're going to have negative 6 plus or minus the square root of that 6 minus 120, this is the square root of negative 84, divided by 2. Okay, so this is equal to negative 6 plus or minus, now the square root of negative 84, we can express this as 12, okay, times 7 times negative 1. Okay, divide everything by 2. All right, now again from here we can express this as negative 6 plus or minus the square root of, we can express further 12 as 4 multiplied by 3 multiplied by 7 multiplied by negative 1, divide everything by 2. Okay, so that you'll have negative 6 divided by 2 plus or minus the square root of 4 is 2, the square root of negative 1 is I. Okay, and then we have 3 times 7, which is the square root of 21, divided by 2. Okay, so that now you're going to have negative 3. If you simplify this is 3, and if you simplify here, you're going to have plus or minus the square root of I square root of 21. Okay, so that means that we have x2 equal to negative 3 plus I square root of 21, and x3 equal to negative 3 subtract I square root of 21. So these are the two complex roots. Okay, these are the two complex roots, and that means that our algebra problem has got 3 solutions as we have calculated. So thank you for watching, and kindly subscribe.